Hello, my dear students. This is Felix Balaji. Today, let us discuss a problem based on center mass and friction. Here, a rope of length 30 centimeters is on a horizontal table with maximum length hanging from edge A of the table. This is the edge A of the table. Here, maximum length of the chain was hanging. A remaining part is on the table here. If it is L, this part will be L minus L. The coefficient of friction between the rope and the table is 0.5. Between the table and the rope, here coefficient of friction is 0.5. The distance of center of mass from A. From A, you are asked to find distance of center of mass. It was the A. From here, you are asked for center of mass. Total length of the chain was L here. For L length, let us take total mass of the chain is M. Then hanging length small l contains what is the mass? M by capital L into small l. Similarly, for this part L minus L length, it will be M by L into L minus L. Weight of this hanging part always acts downwards, M1G. M1 value we know here into G. Similarly, weight of this part will be M2G and it is a normal reaction. M2 value we know here into G. So here friction is acting here. Here maximum length hanging I told. So to hold the maximum length, you should have here maximum friction, not to slip. So Fs maximum, external force are Fs max and here it is M1G. Balance these two. Fs max formula mu s into n. We know here n value was M2G. Substitute to find small l value. We got small l value was 10 centimeters. That means it is a maximum length hanging from the table. Then length of the chain on the table will be L minus L. So that you can solve this one and we got 20 centimeters. This is the length on the table. It was the length hanging. You can see that one in the diagram. It was the hanging length. Maximum length hanging is 10 centimeters and it is on the table. It was 20 centimeters. Now for this hanging part, center of mass will be here. X coordinate will be 0. Y coordinate will be out of 10, center means 5, minus 5. Negative y axis. Here x coordinate will be minus 10, negative x axis, because the center means half of 20. Y coordinate 0. Now apply XCM formula and YCM formula. Here its mass was M1 and its mass was M2. Just apply formula here. M1 mass we know. M2 mass we know. This was X1. This was X2. Apply, you will get the XCM value. Similarly for YCM. We got coordinates of center of mass XCM, YCM. Now from origin to center of mass distance they are asking. Distance between 2 points formula root of x2 minus x1 whole square plus y2 minus y1 whole square. That means root of xcm square plus ycm square. Just substitute xcm value and ycm value. You will get 5 by 3 root 70. Thank you.